Hello everyone, my name is Mateusz. I'm today supported by Alex, and this is our fourth webinar of UMH. Getting started with UMH is the topic of today. I'm just gonna give you a quick intro of what we want to do and achieve today, and then we pretty much give it a go. Yeah, if you on the way have any questions, please post them in the chat. Happy to answer them. We have a few of our colleagues in the chat, and of course some of the community as well. So we are more than happy to talk about any of your questions. So agenda for today will be pretty much a quick intro to us both, then UMH itself, where do we come from, what's our architecture, our product, and then we're gonna go into setting up a VM, so pretty much how to get started from zero, setting up the VM, installing UMH, connecting the first data sources, visualizing your first data point, and then we have a bit of a Q&A just to hear what you're doing, what questions you have left. So as said, my name is Mateusz. As a background, I'm a mechanical engineer, and after that I started to work in management consulting for 5 years and consulted a lot of industries in digital transformation. Now I'm happy to be here at UMH Customer Success Manager and be responsible for more hands-on implementation, not only the PowerPoint side of these things. Today supported by my co-founder and CEO Alex, who's going to introduce himself.
So I'm Alex, I'm co-founder and CEO, as Mateusz already mentioned. I have also a mechanical engineering background, and I'm feeling like I'm repeating myself over the webinars here, so everybody should hopefully already know a little bit bits and pieces. And then after mechanical engineering, I transitioned quite fast with my now co-founder Jeremy into system integration. So directly out of university, we both had a great idea to just set our time as helping other customers like digitizing from like a service perspective, and this is how we met Mateusz. So we were like working with him quite closely in his prior role, and then at some point we like had enough of doing it over and over again as a manual task, and then founded the United Manufacturing Hub as an like automating a lot of the tasks that we had back then as system integrators to then really focus on like creating use case and value out there. And this is also what we would like to show today, like this actually getting it started, because a lot of customers, or when you're a system integrator or user, like the tedious phase of getting something up and then takes days or months before you actually can show value in form of a use case is annoying, and we want to prove that's actually quite fast. So we start today from scratch. So like from a VM, so something that you then need to fight for with your IT force that you then hopefully have fast. But so as soon as you achieve that magnificent goal, which is actually not that easy, you now can just deploy the UMH and completely automate the whole tool chain and then start creating value. And this is a little bit the goal of this webinar today, to show you how easy it could be. Yeah? Before we start, I would like, I'm repeating myself, but introduce a little bit the UMH, the company behind it, to have everybody on the common ground. So we like work on the interface between OT, automation engineers, mechanics, and electricians, like keeping the shop floor alive, and IT people who are like engineering pipelines and using the data to provide use case. And this is why we say, okay, we provide an IT OT integration platform to really not only on the data, but also on use case sides combine those tools. And then our hypothesis, like we saw it back then, and now it's not only like using lean or like process improvements from like a just seeing and applying standpoint. It's more like, okay, which tools you have at hand with technologies and data to then solve your business problems now and in the future. And this is why we say, okay, industrials are becoming tech companies, not necessarily by they providing them in Netflix, but rather by them enabling digital technologies to use and solve their own problems, to be more tech-centric than before. But this is hard. So there's like a journey that they need to take, and this is also the one that we took, like going a little bit back as the system integrator journey, crouching to the machines and connecting machines and providing dashboards in ugly, wet/oily interfaces. And this is why we want to help. We want to make the life of people creating use cases easier through technology. And the way that we want to do that is, this is the new term, this is an architecture, this is a vision, this is the unified namespace, and it is moving away from how data and technology is handled on the shop floor. Like you have this mostly scattered, built over years infrastructure. So you have an MES, you have a SCADA system, you have like a lot of technologies, databases, and integrations. But just getting the data is not easy. So you can go to your shop floor manager and he mostly will say, we have the data. But when asking him how we can retrieve that as an automation engineer, it's like a little bit harder to get there. And this was also an experience. When we want to do, for example, the OE dashboard, we just need machine state, we just need output, we just need quality. But it was actually 80% of the time to actually get the data, even if it was there in some systems and PLCs or MES systems. And the Unified Namespace promises, and we also try to provide the value, say every piece of information is first and foremost at a single point where it now can be consumed in an effective form. So technically, it's an event-driven architecture, so decoupling producers and consumers of data to just make it by definition easier and less middlemen. And secondly, also apply a data model on top so that you can harmonize data across machine vendors and ages to just make, I don't know, a CNC machine, like a motor or whatever, a unique data product that you can then use and reuse across your organization. And if you have both things in place, so architecture and semantics, you are well equipped. And this is also where we want to show you how you can get there like from scratch today. And what do you want to need, or what you need from that seems straightforward. Yeah, so you need means of connectivity. So connecting to S7, connecting to OPC UA, connecting to Modbus, etc., etc. So the list goes on indefinitely, but just connect to the reality and the zoo on the shop floor. Then, secondly, you need a tooling or a process to then normalize data streams across these machine A, machine B, machine C, so that they can look alike. And then push it in the event broker with MQTT or Kafka. Perhaps it now doesn't matter. Store it and visualize it. And then you have your whole tool chain together. But from our experience, it's not as easy as it seems. It's not yet plug and play, because while deploying and specifically while maintaining, there are a lot of more hidden problems. So how do you actually run it? So not everything is, hopefully, and also looking forward, it's not like an Excel that you deploy on a Windows-based system. It's mostly a Kubernetes or like a container-based architecture that you need to deploy and run. So you need to think about that and how you actually deploy it. So across also repeatable across different deployments, about side 1, side 2, inside 1, for edge deployments also over and over again. It needs to be, on the one hand, usable for the IT people to maintain and monitor, but it needs to also be usable by the OT people, because this are the actually guys who mostly then provide the value and have the business insights to move something. And it goes on and on and on and on across the life cycle of the software. And this is why we said, okay, the UMH, specifically the management console, could and shall automate a lot of steps. And to prove that this is true, we provided the webinar today, and Mateusz provided a nice demo. And I try my best to give a little bit of a voiceover when needed. But yeah, this is the United Manufacturing Hub. And this is what we will now build. A lot to consume, but this is the architecture that will now extend your automation pyramid on the data layer. So connectivity, broker, database, streaming, and consuming the data. Perhaps too much for now, but it's a lot of technology pieces that needs to fall into place. But we made it easy, and this is what we want to show now.
Cool. Thank you very much. So without further ado, let's then jump into the basics. So I would like to start really with pretty much zero. So I get a VM, what I do with it, why do we have a specific OS, why do we have specific system requirements, and so on. This is pretty much all what I want to show and discuss. So over here, we have our local Proxmox server. I'm just going to create a new instance. It's going to be just a demo. And then we're just going to jump in and select our operating system. So we are using this time an overall Rocky 9.4. I personally like to use the full image just because there's Nano and all of the other tools already in there. So if you want to troubleshoot, it's very easy.
Yep.
But of course, you would also easily get away with a minimal ECU if you're also interested in that. Yeah. But question to you, like, why do we support exactly this and not others?
There's like, in Linux, there are more flavors than you can imagine of. So for the special breed people and the Ubuntu kind, but it's a little bit like a tree or like a structure. And we like to be on the structure of Linux on the side of Linux, which is mostly supported by Red Hat. So like the actually largest provider of enterprise Linux solutions out there. And Rocky is like actually the similar operating system as Red Hat Enterprise Linux. So whatever you now get from your IT, like Red Hat, so can I get a Linux? They will say no, and then you will insist, and then you will mostly get Red Hat because it's a supported one. And we chose Rocky because it's the same operating system. It's so-called bug-by-bug compatible. Sounds broken, but this is actually how you describe that. Even that we try to, or that the operating system mirrors the complete behavior of Red Hat. And this makes it like the ideal operating system to start. And then you can also port the workload later on to a fully supported operating system or directly to manage Kubernetes or. But yeah, this is why we like it. And it comes with a lot of enterprise features attached, but perhaps too much for now.
Yeah, thank you. And like some people probably are surprised that we are, for example, using that much memory. We have 4 cores, as a 250 gigabytes SSD. It's for a start quite heavy. Like I understand this, but we have our rationale behind it. Like, but what is it exactly? Do we have some examples?
Yeah. So we're providing a lot of software. So you think, okay, 16 gigabytes of RAM, this is out of the ballpark of most Raspberry Pis. Why? And actually, the reason is we provide a lot of technologies on a single device. So if you think about a database, a message broker, a message bus, like a streaming platform like Kafka, connectivity, like you will deploy like hundreds of containers on this device, it actually starts looking way less of a resource demand from us. And we try to start high, that you negotiate already with your IT, like the requirements and the hardware you can then mount and extend later on. But the cores and memories is actually something that you also equip with enough of headroom to then deploy also your own workloads in the Kubernetes cluster. And it's small enough to actually be compatible with most edge devices / edge servers that you can actually run. 8 cores gets unusual hard. 4 cores, 6 gigabytes is something that you get actually mostly in configurable devices from OnLogic. So this is a little bit how we set that numbers.
Yeah. And I can definitely confirm it's nice to have a bit of headroom, especially if you connect like a huge OPC UA server, 5,000 plus tags. You should not underestimate what load this can create.
And we are deploying like full Kubernetes on it. So like small Kubernetes, baby Kubernetes, K3s, but normally this is then designed for workloads of, I don't know, 1,000 CPU cores, etc., etc. But we shrank that down to be applicable for manufacturing.
Yeah, so as you've seen, we're just setting up a user allowed to connect over SSH, so you can actually get into the terminal, and then we pretty much start the installation. So this will be it when it comes to configuration, as vanilla as possible to make your life and also your AT admin's life as easy as possible. Then we're going to start the installation, but let's not wait for these 15-20 minutes, how long it can take. But let's maybe just jump into the webinar VM that I already created. So I have this one over here. It's the 1.6. It's currently running. And let's take a look how we can actually install the UMH with one single line of code. So over here, this is the management console, management.umh.app. You can just sign up as a free user. The community version, no big deal.
This is also all what we want to show is completely possible with the free version of the UMH. So no strings attached here. You can just, after the meeting, get your favorite VM and do it there.
Yeah, exactly. So over here on the homepage, you will see some details, also links to the latest articles and so on after we create the first instance. But this is pretty much the most important step over here. We're just going to call it webinar. We're going to select the classic, which is pretty much the full stack. There's also a UMH Lite version, which is more for edge devices to actually just collect data on the edge behind firewall and just push it to the big instance so to just bridge different network segments that you have with minimal invasion. Yeah. And then over here, you can select the release channels. So we have enterprise, stable, nightly. I think stable is quite easy to explain. Enterprise is, as you can imagine, even more tested. And nightly are pretty much all of the latest and greatest releases that we have. Some of them are a bit more in the beta version. So we're using it internally. Also, the community uses it for testing, understanding latest bugs and bug fixes. But yeah, if you want to have the best possible stable experience, go for stable. And once your customer offers, of course, then we're going to do additional tests prolong a bit of the testing and then push the enterprise features a bit later.
Just to do the stable, like nightly is also stable and full end-to-end tested, but there is not something like 100% guarantees on anything in life, and specifically not for software that is stable. So one dimension that you could increase stability on software is actually exposing it to more users. So you know it when like teams get updated, some of your colleagues that have it and you don't. And this is by actually this stage rollout procedure. And actually this is similar. So you just roll it out to a lot of, this is also why we love to be open source. So we have a lot of community users. Some are more brave, they go for nightly. Some of them are more like they want to go stable. But then we really, really guarantee that as further down across the release channels you are, the more stable the software is. And this is actually also a unique thing by being open source, that we can test and run our software through a brave community. But we test upfront, don't get me wrong.
Okay, so on the right-hand side, we see I added the location of the instance. So we have already a bit of a populated template, and then we click on Add Instance. And what you get is this single command line, which is the only thing you need to actually install the stack. Yeah. So
this is also something super important. You just saw this architecture slide, overwhelming. I don't know Kubernetes, I don't know Kafka. UMH is not usable for me. You're also not an operating system expert or a Windows expert, so you don't know the integral parts of how a kernel works, but you're still able to work with Windows. And the similar we apply here at the UMH. So we in the product manage the dependencies of the software for you. So we take care that Kafka is working, we take care of Kubernetes is working, and we take care that both softwares are work together. And you just need to be abstracted and use the software on top of it. And this is just a single command that you need to be able to press, and no need for further Kubernetes action on your side.
Yeah. So on the right-hand side, you see my terminal. I just SSH'd into the instance that I prepared before. It's very similar resources, so no big difference when it comes to speed.
Make it a little bit larger, Matthias. I'm not, perhaps a little bit, we have a larger screen here.
Yeah.
Which Command Plus? I think it's
Command Plus. Let's see. There we go. Perfect. So this is it. Press Enter, and immediately we are starting to download all of the required files and pretty much running through the installation.
And this is actually your free system integrator now running as a robot in the background.
Yes.
So you're catching all the dependencies, all the software pieces, putting the Lego together for you, and providing you with a complete software stack at the end. And yeah, this is actually also a war story. When we started as a system integrator, like we deployed like Edge.
One thing over here. So you will see typically the question which IP address you should use. So this, the installation script recognizes the available IP addresses, Ethernet adapters in your VM, and you can select this IP address which you will be also able to reach from your internal network. So later on, once we have Node-RED, Grafana deployed, Kafka, and so on, this is pretty much the IP address with the additional port of it. So like in terms of Grafana, it's like 8080. Where you can reach the visualization database and so on and so forth. Yeah. So in this case, this is our 1013 and so on. And just type in 1 and can continue with the installation.
So don't just press again yes. That's the host name.
Host name, just in case, because K3 Kubernetes in general is a bit sensitive if you change the host name by accident. So yeah, we also called that one.
And don't change IP addresses, just to this is also what Kubernetes doesn't like. Also after deploying the stack. So like when we started before UMH, there was one job for one of our customers was to provision edge devices, dozens of them, to just put software. Back then was Influx, Grafana, Node-RED on a thing, deploy it, configure it, and ship it out there. And this process was like all-nighters from here in Germany. Get it up, it was highly fault not tolerant. So you need to go to Influx, create a token, get a token, put it to Grafana, etc., to make the software work together. And this is completely automated in here. Like the integrations and the deployment of the software in each other is something that you don't need to customize. And so we automated the whole inner living of the software here.
Yeah, because in the end, we all just want to have a working product, not the newest version of everything, but really just something that's still more productive.
Yeah.
So while this is running, let's maybe draw the vision a bit where we actually want to go with such an IT/OT integration platform. So over here, I have the demo version running of our management console, and here is our namespace, the Unified Namespace, in the tag browser. So we always structure our unified namespace with ISO 95 hierarchy, which means we start with the enterprise, in this case the demo, and then per site we go into different production areas. Could be paint shop, assembly, could be also on a higher level ERP data. In the assembly area, also the specific production lines, and within these lines, then the assembly, machines, and so on, and then pretty much all of the information that we get from these machines, which is then for automation engineers, data scientists, anyone who's somewhat familiar with the shop floor, super intuitive to use because they know, hey, I just want to connect or visualize data from machine and whole to. Yeah, it's going to be this site. I know it's, a machine is called this, it has this unique identifier. It's very similar to what we already have set up, maybe in SAP or any other asset management. We have the full flexibility to set it up, but we definitely recommend ISO 95, which most of you are familiar with anyways, just to use that. Yeah? And then on the right-hand side, which is then amazing, you just have immediately the last 100 data points to see, is this actually the correct data point? Like super interesting when you read out Modbus, like do I have the right registers? But a bit more to that later. And over here, you then have the automatically generated Grafana query. So as you see on the left here, we have this underscore historian schema tag, which means that all of the data that you see down below here is automatically stored within the database. So once you set this up, it's there. You can immediately access this over Grafana, copy this SQL query, and then you very much easily and very quickly able to go. Yeah. If you're not interested in historical but real-time data, could be for notification alarms and so on, or maybe to push data to any other sources that you have. MQTT and Kafka are also available. You have the full payload, headers, and keys and topics over here as well.
And there's also like a question already in the chat regarding data normalization. To some degree, we get to it, but I think this will be a full own webinar on how you actually do it. But can you go back, Mateusz, to the data contract? So like these underscore things, this is actually what you would like to create. Like you have a complexity of different machines and types, but you want to normalize them on a data level. So like I said, pump looks like a pump and not like a pump from vendor A and a pump from vendor B. And for example, the historian data contract is like a guarantee on the data level. The data always comes in a certain format. So for example, with a timestamp, a value, and some meta information attached, which is a might and not a must. And then you can guarantee the rest of the pipeline. So if a message arrives in the data contract, then you automatically insert it into the timescale DB. And you can now think that more and more for work orders, for new products, etc., where you can then automate a pipeline of incoming data based on the schema. And these are data contracts. I will come a little bit back to that later. Try to be.
There are definitely a few minutes left in the end.
And there was also one question, perhaps I can grab it already, regarding ARM compatibility. So the UMH Lite one is ARM compatible. So like the one that you could deploy behind DMZs where you really want to perhaps use an industrial Raspberry Pi. The full-blown stack is not yet ARM compatible, to be honest, because we don't have like a lot of people actually requiring that, because this is a server-based workload and servers are somewhat already in the cloud, but definitely not yet on the edge or like in a local VM on ARM. So we will follow up on that as soon as the priority arises, but the edge device is already ARM compatible.
Yeah. So on the right-hand side, you see after a few minutes, installation is complete. And if I go back now to my management console, you see now over here that the instance is running. Let me maybe increase the size of it to make it easier for you. So instance name webinar, type is classic, the latest version, and over here you see additional information. Yeah. So over here on the right-hand side, you see pretty much every single version of the pods we are using. So -q, Kafka, our simulators, Grafana, and so on. And
there was also a question regarding a directly MQTT broker, because
there we go.
We use -q Community Edition.
Yep.
So so this is we made a lot of blog article. So Jeremy did one back then, and the result was -q for various reasons was the favorite one. All requirements regarding MQTT are not that high, so it's replaceable theoretically, but to do that, there needs to be a strong reason, and we like -q and specifically -q Enterprise Edition. So for more demanding workloads, or if you connect like a huge fleet of AGVs, this is also like a valid reason to go then the extra mile and go -q Enterprise.
Yeah, especially in connected devices, cars, and so on. This is then I think a no-brainer. Yeah, pretty much. And then over here you see the infrastructure. we see immediately if everything is anything is off, number of cores, memory, disk space, and so on, and modules, which is especially interesting when it comes to the database, our bridges from MQTT to Kafka, Kafka MQTT back, and so on and so forth. So everything in one spot to really monitor what is going on and understand if something is off.
And all wielded by Pain, if you want. So like it's something to create like fancy dashboards of some moving numbers and red and blue and green statuses, but like setting up the infrastructure as once, but then keeping it alive is something different, and having at a glance the most relevant KPIs for the state of the HDD, of the CPU, of all the relevant components, like aggregated and non-aggregated, is quite crucial. And this is why we introduce and will more and more also add more monitoring capabilities to then put like a non-Kubernetes expert in a position to manage a Kubernetes cluster without knowing how to manage a Kubernetes cluster. Like learning a lot of it with a vision for that, yeah.
So we have now pretty much the vision ready. We have the instance ready. Question is, how do we bridge actually this? Yeah. So once we have it set up, over here on the left-hand side under connections, we have our first two simulated connections. But let's start maybe with a new one. So our VM is running in the local network where we actually have set up Kepware with a couple of tags. So let me just connect to this.
And this is also not an or, it's mostly actually an and when we see Kepware. If you have a really crazy zoo of connections, like, I don't know, 50 plus protocols that you need, there is no better tool out there than Kepware to actually get it. It's not perfect. It's mostly Windows-based. It has limited monitoring and logging capabilities, but it's mostly stable and working. And like a good way to get actually the long tail of connections up before you move them further and further to more modern and standard protocols.
Exactly, also especially for a reasonable cost. Yeah, sometimes it's not even worth to talking about how to transform these payloads, but just use Kepware and then just call it a day. Yeah. So, but I'm going to use Kepware as an OPC UA connection example. Of course, you could then connect automatically to any OPC UA servers or process or any machine vendors that you have. And over here, after you set up the connection, which is pretty much showing you first the latency, and then on the second also the stability of the connection. So also like, is the port open? Yeah. So after you set up the connection, pretty much someone from IT can say, hey, my job is done. Yeah, your networking is set up, your firewall is set up, you can reach it. Now I hand it over to automation engineer, process engineer, who's actually understanding the machine, understanding the data points, understanding how to translate these to business relevant data. And yeah, how to do it is by adding this protocol converter. So in that case, set Kepware OPC UA. We're going to select one of our templates over here. And immediately on the right-hand side, you see our OPC UA browser. So, which is pretty much already read all of the tags that we have in there.
This is also like another pain point, because what you normally need to have is like UA expert and the Windows laptop directly next to the machine to then read out the available data points from the machine. But mostly you're in your cozy office, or you're not. I think you're on the shop floor, but often not directly attached to the machine and the interface. And this is why we took the functionality of browsing, pushed it onto the server, and now serve it actually via the front end to make your life easier bit by bit.
Exactly. And over here on the right hand side, you can select specific nodes or like the whole root folder, like we have over here with I equals 84, subscribing to everything. But of course, we can also just go for single data points over here. Yeah. So do we have anything that could be super interesting? Otherwise, I'm happy to subscribe to everything.
Get everything. Why not?
Yeah, let's just go for everything. Yeah. There we go. Apply. Opa.
Scroll up.
Yep. Just like not being, but it's
okay.
So what we have over here on the left is a bit of configuration. So you can type in your credentials if your server requires. Define also specific certificates or any encryption that you might have. And down below is where the magic happens to actually build up your unified namespace.
Also where the data modeling or data normalization happens. It was requested before.
Exactly, yeah. So over here we start, of course, with where do we want to put the data. So some of these are pre-filled. I already installed the instance with some of the environmental variables. So this was webinar. limited as a company, Cologne Studio as further broken down location. And the schema is going to be underscore historian because I want to immediately collect all of the data in our database. Down below, you have meta, OPC UA tag group, tag name, and so on as variables from the OPC browser, which then also can be used to, based with an if statement, change specific locations of folders or rename and so on. Especially for rename, I also have an example later on where you can pretty much match specific tag IDs with something that's humanly understandable. Super interesting when you're reading S7, because typically you see like DB02. 0.1 something, and then this is pretty much the data point, but it's actually a temperature. So you want to standardize these data points immediately already here by the automation engineer or anyone else that understands the machine.
This shows also a little bit our architecture and product rationale on that, because what you could also do is drag and drop individual node IDs from them and then override every specific property and JSON schema based on that input. But this is perhaps for the first time user good, but we also optimize for that. But specifically, if you now work through a 30,000 tag OPC UA server, you don't have time or resources to do that. And this is where then code-based workflows are so much more powerful, and specific regex and like replace functions. And this is why we then have this like limited, but also in the sense of you don't need to do everything with code, but specifically the processing part, to then make it actually easy and fast to scale your data processing and connectivity, then don't waste time on tedious and repetitive tasks.
Yeah, especially if you have like 20 machines, every single one of them has the same PLC, same data points. And just want to have a template, reuse it, call it a day. Not click through pretty much UI to just do all of the same steps again. So we have selected it, we know where we want to save it. Let's just save and deploy. So for this specific connection, and every single connection, we pretty much create an independent container. This is managing the connection, the monitoring, all of the data transformation, and so on. And which is very cool if it breaks down because the connection, like something is off. I don't know. You lose power, you lose connectivity, whatever.
Or you mess up the configuration.
Yes, could also be the case, right? So no component of the system is really affected by it. It's really just a single container. So this can break down, you can update it, roll back, and so on without affecting any of your existing infrastructure, which is huge compared to any OPC UA server you might have. Could be Aviva, could be Kepler, where sometimes, it broke down, I have to restart a whole VM just to get it running.
And this is also like this is not only for Node-RED, but a good example on the limitations, a little bit of the architecture. So we deploy one container per connection. So if one messes up, it doesn't affect the others. But most tools out there, either Windows-based or already container-based architecture, are one single binary for all the connections. And so there's Node-RED used for data ops and flows. We say it's in the mix because it's good for prototyping and getting stuff done and also building some UIs, but it's not good for handling large-scale set of data. First, use the overview based to flow-based architectures. Second, it's hard for collaborating. It's get messy, and explaining that to somebody else is hard. Third, you have a hard dependency on the nodes who somebody else developed and not the company who's actually providing Node-RED. And this puts you in a position when every 6 months Node.js gets updated. It can break, it doesn't need to break, but this is high risk attached. And we have it seen if you mess up one flow, and it can corrupt the whole deployment. And so, this is limited disadvantage. It's a cool tool, good for prototyping, good for actually building some HMIs, but for this heavy and scalable data processing, we don't see it.
Yeah, definitely happy to use it, especially in the beginning. Just understand what is the data, how does it look like, get some POC running, can be nice. But as you see, container is a single container started. We're also checking for like 10 seconds if there are any noteworthy error messages to really ensure that whatever you deploy is also stable. Now we go to connections, it's immediately over 1,000 data points that are being logged here.
Per second,
Per second, exactly. So I guess Kepler is dropping some error, but let's see how it's going to behave.
It could be too much for Kepler, but
let's see. So besides this, what other data points do we want to connect? I think also S7 would be quite cool, as a lot of you have some Siemens PLCs running. So let's go for S7. This is IP address. It's going to be the standard 102. And let's call it actually S7 to make our lives easier to finding it later on. So checking the connection once again.
That's also one more question. In the meantime, do we have an OPC UA interface? Yes, you saw like to connect two OPC UA servers, yes, but we don't have our own OPC UA server then to consume data. For that, we have MQTT, Kafka, and SQL as interfaces. Yeah.
Yeah, so as you see over here, I selected Siemens S7. It's a different template. And of course, per communication protocol, you have different settings. Yeah, so it's always going to look a bit different, but you try to make your life as easy as possible to get started ASAP. So over here, you then just type in your addresses that you have. And further down below here, it's pretty much very similar. Yeah, you have here a match statement referring to the specific address, so this DB1 and so on, and then renaming it to counter, to temperature, and so on. Yeah, this is then the amazing power of it. You just have it in a single template. You can reuse it for any connections and so on. And if you just change this, yeah, and it's very simple to also maintain it later on, yeah, if you for some reason change it.
And we're also introducing a feature in a short future to actually, in the processing part, use JavaScript. So currently, it's Go/Bloblan, and this is like it's not like you need to learn a complete new programming language. It's just that is a little bit unfamiliar, and you want to reduce that unfamiliarity, and therefore introducing JavaScript in the processing, because this is one thing, for example, Node-RED does Gate. It's so easy and approachable, and we also want to provide that to you in the processing part.
So ideally, you can just copy paste the JavaScript in your Node-RED flow, and then just reuse it over here to do outbound data transformation, and then really ensure that it's, whatever you implemented or connected is very similar to what you did before. Yeah? If you have any specific questions to any protocol settings and so on the right-hand side, this is Protocol Converter tab. And you can open it. It's going to be specific for every single connection type. And then you have all of the documentation that is required to do all of the nitty-gritty settings that you sometimes might require, also including some examples, how to rename variables with an if statement, match statement, and so on. So everything is here, or otherwise on the GitHub repository if you want to go really deep into the code. So save and deploy once again. Not sure if the data we get from this specific S7 is meaningful, but we're definitely going to get at least some bytes. And I think besides this, last but not least, I think Modbus.
And the simulators, that's also something that we could show.
Yeah, I think let's just use the Modbus simulator that we have also over here. So we don't have to connect it, but I think it's interesting to see how we handle Modbus system over here.
This is also something that we ship to make your life a little bit easier to try it out. As you get a VM, but also now getting the VM in the same network can also be like another challenge. So to validate it, not only via the demo mode, which is available via the settings, but also in your environment, we ship those simulators already inside the Kubernetes cluster to then connect from inside the Kubernetes cluster to then just validate and play around on your own.
Yeah. So over here, Modbus, you just you connect to the Modbus gateway, and behind that you have Modbus RTU devices which have specific rack IDs, slave IDs, however they are being called, and then you can specify additional ones, 2, 3, whatever numbers you have. Define with registers, and what type, output, and so on you want to them to read out, and then pretty much do very similar operations to position them correctly in the namespace. Yeah.
Oh, there's a good. This I want to show later. Fabian wrote a good question. Agree. let me say how we sort that now and even better in the future.
So let me just go for Modbus over here and then save and deploy. So I think these are the most common examples that we have. Of course, MQTT also quite common, but most of the times more about environmental data already, working with data that's already was being connected. Yeah, because most of the times you will have these machine protocols on the shop floor. So now we pretty much loading everything that was already pushed forward to the our Kafka broker. Yeah, so immediately see over here.
One thing, like how does it work? So you're in the front end, you're not connecting to that. So what does it do? The front end asks, hey, my connected instances, I would really want to browse all your text now. And it requests like the schema and the structure from it, and it now gets back to you on the front end. So we not have access to the data. We are requesting a sample format, which is then also end-to-end encrypted, so that you can use it without like compromising that. So it's not in the cloud, just to say that.
Most definitely. So all of your data is on the infrastructure itself, on premise, which is also the amazing part about having your own cluster. So over here, you have exactly this root folder from Kepware, where you can drill down specific data points
like a
see,
float. So it's super interesting.
yeah, see what you can collect over here. Yeah, you see how much it's pumping out. Yeah, no wonder it's like 1,000 tags per second. Once again, you can just copy this and then start working with it. Yeah.
And the mighty part of it is actually, if you already have a great structured OPC UA server, you can just import it into the UNS. So yeah, you can copy and lend the structure that is like below the OPC UA server, like the folders below, and then just push it to the event-driven architecture. Yeah, so this is how we do that. And can we go back to, so one thing, so here's sometimes good stuff hidden. This is Pictureplex. This is something that we're currently rolling out, but don't feel yet quite comfortable for like showing everybody. So sorry, Jeremy, to showing that to people. But so what you could do now, let's use that here. OPC UA. So this is like true, like this. Fabian asked in the chat, let me close that down. Fabian asked in the chat, hey, Bentor is super powerful, but how do I validate? It's a bit of a nightmare. No, sorry, didn't say nightmare. He said hard to grasp. And now we want to make this processing and inputting step-by-step testable and then also easier to iterate and faster and overall. And so what you could do, now we introduce the so-called, this is still, I think I didn't browse it fully through. This is also why it's behind the test flag, but what does it do? It will now provide you the data points from the OPC UA server, so that you can now see the structure in inside JSON, for example, to then just make data processing easy, and will now increase those test buttons for all parts of the processing step with an even nicer UI, but then making Bentor / JavaScript in the future even more powerful. Yeah?
Okay, so after we have everything in the tag browser, let me just close this. We also have Grafana and Node-RED as set. Yeah, over here you can immediately access it. Let's just store this password on our clipboard, connect to this specific IP, go get admin.
This is also one part of the like normal boring work, like creating and managing passwords. So Kubernetes sets it up for you, that you have just secrets created that you can just use and store, etc. Yeah?
Now, this is now fully operational Grafana container. Over here, when you create a new dashboard, you will find this little toggle, change it to code, go to your tag browser. Let's maybe just, let's just go from this Modbus data over here. Could be this point. Just copy paste this specific SQL query, type it in here, run the query, and let's see, let me maybe disconnect this Kepler instance. This is potentially causing trouble. There we go. So here we have the data tags. Let's see. Yeah, the technical issues I was not looking forward to. There we go. So here we have at least a single data point just by copy pasting this query over here. Which is really cool about just copying this query is you also have this drop down over here. So you see it's just simple SQL. The only difference is that you have something that's Grafana specific. This is this $, interval that you have over here, which is pretty much the time filter of Grafana. But you can also use different queries. So for example, if you want to aggregate the data in 1 hour buckets, you can select it. Immediately you will see it over here, which is very nice if we have tons of data. It's not changing a lot because loading 40,000, 100,000 data points into a Grafana visualization can also bring it down. Yeah. So this is why we use typically the aggregates. In Grafana it's 1 minute, but if you really want to see the raw data on your own risk, you can also go for that one. Click this and then immediately see everything in the highest possible rate that you want to have. Could be relevant for any vibrations, voltage spikes, and so on for energy management if you really require it. Then you just throw it in here, run query, and then start normal visualization would do. Yeah. So as you've seen over here, this is the database. Everything is already included, and there is not this nitty-gritty. Okay, how do I connect to the database? What are the credentials? Which table it is, right? All of this little details that you have to really collect, including also sometimes like creating the SQL query that you need. Yeah, can be tedious. So we automate as much as possible out of it. One more thing. So collecting this data is great. Of course, starting visualization could be as simple as that, but a lot of times you also want to do something a bit more complex. So some of you might remember it from one of our last webinars. This is a bit of a division where you can go with Grafana and our UMH. So over here, you see, pretty much our vision of an operator dashboard where they see the current machine state, orders, products, the most important KPIs, including OEE breakdown and so on, data from MES or ERP when it comes to order, cycle times, required quantities, and then machine states with the orders running over here. Yeah, let's just maybe scroll in over here. Just really cool. We also are able to not only collect machine states, but also then change them later on with the CY and Grafana. So having the operator input. So for example, connect, I see this unload stop. I would like to add a bit more details as operator. Let me just choose a reason, damaged cake. And then, yeah, cake is damaged. Yeah, what can I do about it? It's not my fault. Now it's documented. Yeah, everyone knows, hey, the machine was not faulty. There's a quality issue. Later on, you can run analysis on it, export it as a CSV, hand it off to the data scientists and so on. So stuff like this is then easily possible with Grafana once you have the data in the unified namespace, standardized manner, easily to export, everything running with anything accessible over SQL, and then such a flexible tool like Grafana.
Yeah, this is actually also what we see lately is actually also the whole discussion on how when you modernize your MES system, which functions UNS is not an MES, but it's a great foundation to get it actually started, and a lot of requirements for like transparency in the shop floor input back, like setting something is now finished, and etc., and giving like an actual to target visualization on how he's producing currently as a shop floor worker. Grafana can be actually quite powerful. So it's more about now the UNS at its core and combining architectural pieces and apps on the side to then fully modulate and provide a modern MES solution, a composable one, would Tulip now say.
Yeah, that's pretty much it from what we wanted to show how to get started with UMH from installing your operating system, pretty much visualizing your first data points and having a vision where you want to go with the use case. We have still 10 minutes left for any questions, so please feel free to chime in, let us know what you're interested in. Otherwise, we're also going to use the time for I think 1 to 2 polls. Our colleague is going to help us on that, just to understand what you're currently working on. I think this would be the first super interesting point that we'd like to see.
There are some more questions that I can also then chime in on the meantime.
Yeah, please do.
Cool. So I think the Ubuntu Core plus Rocky Docker container, will it work on Edge or on EdgeX platform? So there's 2 ways. So every Rocky-based operating system, 9.4 onwards, that a UMH can be stored on. But what not will work is actually having like Ubuntu as a base foundation operating. It can work, but we don't recommend doing that because something can go wild there, and this is not something that we then want to we will want to help you, but just use Rocky because it's also open source. And you can then now, if you have like a container platform, like I expect EdgeX to be it, you can also then use UMH Lite as a fully packaged Docker container, so just not as a full Kubernetes cluster that you then deploy on the operating system level, but package it as a Docker container and then deploy it inside some other runtime, container runtime that you can, then doesn't matter which operating system is actually underlying.
So what do we have over here? What's the current state of our attendees? So we see that 70% of the respondees are just getting started. So we are at the initial planning stages and digitizing their factory. A few of them are already midway through, and one actually is already well established. So cool that you're also here just to understand what's out there and how you could improve or what's pretty much the state of the art. So
this is also like getting started in now 52 minutes. This is the hyper that we want to provide. So like democratizing a little bit on how easy and how cheap it is actually to get started. So you don't need to consult McKinsey or somebody else to draw you some PowerPoints that you then give a system integrator or system house a few millions to then implement. And then after 1.5 years, you can actually run it. So it's already commoditized, open source and out there, and you can start using it now, and specifically on a grassroots level. So if you're just on a plant level and want to have finally something to digitize your operations, you can do it now like detached on your own, and then later on migrate it into the enterprise requirements and structures. But again, reduce overhead, increased automation to move really, really fast, because time is something that we don't have as nobody out there. And this is why we want to save you a lot of it.
Yeah. I think let's also do maybe a second poll, because I'm super interested in what the community is also thinking about use cases. So what's the most relevant for you at the moment? Yeah, in this current situation, I assume energy and OEE should be quite high up there, unless we have some folks from food and beverage and pharma over here.
Regulatory.
Yeah, specifically European Union, Germany. Yeah, depending on the company size, it's a huge topic now. OEE, condition monitoring is always out there. But yeah, also depending a bit of your stage. Typically in a digital transformation, this is the first use case that you go for because there's so much potential in there. But of course, really depending on your current situation.
There's like another question. I'm not sure it's the statement. We are running Rocky Docker on Ubuntu 24. Yes, if you use a Rocky base image and deploy that on an Ubuntu operating system, you can do that. And this is also the same thing that we would do if you now use UMH Lite in the Docker container, which then also I think is please correct me, but I think it's also a Rocky base image compacted into a Docker container, then you can deploy it on any operating system. But using the non-containerized version of the UMH and then changing operating systems is actually a lot not harder, but yeah, it's a lot of bells and whistles and moving pieces.
No, there we go. So what we have, OEE, the big favorite as always. A lot of people are working on that. Energy, resource optimization, also a big topic, and actually for some also open source historian. Really cool. So yeah, talking about the big historians, how much they can cost, what the performance is, and yeah, sometimes they can be a bit difficult to use. Cool that you're exploring these options because we are a huge fan of timescale DB. Yeah, pretty much Postgres, super boring since 25 years out there or even longer. A lot of people know SQL, just adding some time series database capabilities on top of it, and you have something that's really, really cool to use and super performant as well. So cool that you're here. And yeah, OEE, also good that we then had this operator dashboard as an example, because pretty much
it's
relevant for everyone.
We uploaded the template also somewhere, I think in one of the OEE specific webinars, so you can steal from us.
Please do, yes. Please also give feedback to that if you have any more ideas what you would like to see, because this is what we, as an open source company, also live from your feedback, from your input, from your testing, and later on also any bug fixes. Whenever I think about a new OPC UA server, which is a very special kind of flower, and we're making pretty much our product, and by that also your system more battle-proof. So looking forward to your input. And
also regarding the open source historian and like the UNS or the architectures that we're building and that you hopefully also now execute is has an overlap of existing systems, like storing data and visualizing, storing and distributing data and triggering actions, SCADA. You have like the planning, visualization and reporting functions of an MES, etc. And it's not that you should now throw everything away, put the UNS in there. So we say, firstly, extend the system that you already have there, like empower them with additional functionalities and use cases. And then over the time, you will see what you still need and what don't, and then move piece by piece to this event-driven architecture to then fully utilize the scalability and also cost-saving effects by eliminating a lot of software that's already in the shop floor. But not start with it, end with it.
Cool. Any more questions from the chat?
I think some of them perhaps I can do then after the meeting, or we can later on.
Definitely, if you
put them in the community, and this is also the call to action. Would love to see you all online again in the Discord. So it's one thing that we are now here in the camera, but we want also to give the people back of the camera, like you, like also the chance to talk to each other and also about the experience that you had with the UMH. So we have a Discord channel, like 900 plus people in there currently and growing. and please join it. You can find other like-minded people to discuss UMH, what's great, what's not, give us feedback, and about perhaps if you have found bugs, also report them there. We want to build the best product out there, and this is actually a function of people who are using it. So go there and explore. And yeah, it's great that you are here.
Thank you very much for your time. Looking forward to see you on the next webinar. Topic will be announced shortly, also the date for it. So stay tuned. And yeah, thank you much for your time once again. See you soon.
Have a great week. Bye.
Bye-bye.